All right, I believe I am live. Let me share so that I can put this in my Google Classroom so that anybody can come join us. So let's post the link here and make it available to all of my FOCS classes. All right, I'm a few minutes late getting started here. Sorry about that. Um, about 6 minutes late. That's okay. There's nobody on here yet. Live on YouTube. 11 a.m. Going over lesson 18 on code.org. Let's add a YouTube link. Do that. Did I share that to all my classes? I forget if I did that. Let's make sure that made it to every classroom. I got 2 people viewing so far. Welcome in. Say something in the chat so I know who is watching. No, this did not get shared properly across all my classes. So let's do this. Add YouTube. Make sure it gets shared with my other classes. And I am live. Whoops. Live on YouTube, 10 a.m. to 11 a.m. going over lesson 18 on code.org. Alrighty. So that takes care of that. So it looks like we have about 4 viewers so far. Hello, hello, and welcome. We'll be going over lesson 18 today. Say hi in the live chat if you're here, just so I know who I am working with today. Nobody's talking in the chat. I didn't have breakfast yet, so I'm kind of taking care of a smoothie right now. Getting some good vegetables and fruits. Making sure I stay healthy. Ride or die. Who is that? Are you one of my students? Oh, Jose Henry, welcome. All right. If you need to go over lesson 17, there are 1 or possibly 2 videos that I did live streaming last week where I went through all of lesson 17. So if you go back to the Google Classroom, you can find the videos on lesson 17. Today I'm going to be going through lesson 18, and I want to try to open this up to a Q&A. So if anybody has any questions about specific parts of any lesson that they would like me to go over, I'll actually start with that right now. Are there any specific levels that anybody wants me to go over in lesson 16, lesson 17, from any other previous lesson before I get started on 18? Is there anything from before lesson 18 that you would like me to review? I'll give a minute for people to respond. There's about a 10-second delay So when you type your response, it'll take me, well, you'll be seeing me saying it 10 seconds late. So it'll take me about 10 seconds for you, for me to see what you're typing. Good morning, Anjali. Anjali. Does anybody have any questions about anything before lesson 18 before I get started? I'll take this silence as a no, and I will go ahead and get started on lesson 18. Okay, the class programs their sprites to interact in new ways. After a brief review of how they used the is touching block, the class brainstorms other ways that two sprites could interact. They then use is touching to make one sprite push another across the screen before practicing with the 4 collision blocks: collide, displace, bounce, and bounce off. Abstraction, this is the vocabulary word that we learned from lesson 16. It just means to make things more simple. When we use abstraction in coding, we're taking a complicated idea and we're usually writing one line of code that covers a whole bunch of things. So a lot of these sprite.bounce, bounce off, collide, displace, they all are a form of abstraction. So we're going to continue to level 2. In level 2, sprite interactions. So far, you've been able to create simple sprite interactions by using the sprite is touching block. For example, you've reset a coin to a different location on the screen when a character touches it. Now it's time to start making sprites have more complex interactions. So we're going to make the ways that sprites interact with each other even more complicated, even more complex. Run the program and observe the interaction between the two sprites. All right, let's do that. Let's hit run here. I'm going to make this a little bigger. Interesting. So when the giraffe touches the monkey, it moves the monkey off the screen. So discuss with a neighbor. So we're just going to kind of think out loud here since we're doing a live stream. Using only the commands you already know how, could you create this kind of interaction? There are many ways to do it, but here are some blocks to consider. So lots of these blocks, we could use several of them, but let's think through this here. So using the commands you already know how, could you create this kind of interaction? So how could you create this interaction? The giraffe is moving, right? What code would be used to make the giraffe move horizontally? Well, that's going to be sprite.velocityx, right? So we could give the giraffe a velocity x sprite. Sprite is touching. That's going to be something that kind of happens when the giraffe hits the monkey, right? So let's watch this happen here. The giraffe is moving, and at some point, it starts touching the monkey, and then the monkey starts moving. So that would give the monkey a velocity x. So it seems like we could make this happen by using is touching and velocity. But we might need an if statement in there as well. So let's move on to level 3 where we'll tackle this. Let's do version history, start over. Okay. Waiting for it to load. All right. Program a sprite interaction. Whoops. You should have discussed with your classmates, well, in this case, just kind of thinking about it since we're in a live stream, how could you create the sprite interaction you saw in the last level? Now it's your turn to program it. Oops. To program it yourself. How can you make the giraffe move the monkey off the screen? So do this. The giraffe is already moving across the screen toward the monkey, but the sprite interaction itself hasn't been programmed. Use the plan you developed with your classmates on the last level to program the sprite interaction yourself. So right now, when we run the code, let's take a look at what we already have. The giraffe is going to move. It's moving, it's moving, it's moving, it's moving, it's moving. And when it touches the monkey, we want the monkey to move too. Well, that's not happening right now. Right now, the giraffe just kind of goes past the monkey and the monkey doesn't move at all. So we need to program so the monkey moves when it's touching the giraffe. So we should know how to do this from lesson 17. This should be pretty straightforward. The first thing we need is an if statement, right? If what happens? If some event happens, we want the monkey to move. If the giraffe touches the monkey, right? So the order of this right now with is touching doesn't matter, but it's going to start mattering soon. So let's think about this. Let's write it as we'd say it, right? We wouldn't say the monkey's touching the giraffe because it's the giraffe that's moving. So it's the giraffe that's touching the monkey. Giraffe is touching monkey. What's going to happen? We want the monkey to move. Monkey.velocity x becomes, well, what's the monkey good? How fast is the monkey going to move? We want it to move as fast as a giraffe, right? We want it to move. Yes. Oh, I see. Jose Henry put sprite is touching. Yes, that's correct. Very good. I didn't check the chat there when I asked that question. That is the correct answer. Sprite is touching is what we're using here. Giraffe.velocity x is equal to 1. So it looks like the giraffe's velocity is 1. So we could read that and we could type 1 in here. We could do that. But what if I wanted to change the giraffe's velocity? I would also have to change the monkey velocity. I might forget that code is even there. So there's an easier way to do this. Well, it's a little more complex, but it's an easier way to code in the long run. If I want the monkey to move the same speed as the giraffe, all I have to do, the giraffe's velocity x right now is already 1, right? There's a value stored in giraffe.velocity x. So I could literally put in here, make the monkey's velocity equal to the giraffe's velocity. And so now, whatever the giraffe's velocity is, the monkey is going to match it. So let's watch and see if this works. There we go. Very good. That's it for level 3. Continue. Level 4. In the last level, you should have written code for a sprite interaction that you developed with your classmates. This time, try to write the program on your own, but you can use the patterns you saw in the last level. Excuse me. The elephant should push the hippo off the screen. Notice that the elephant moves at a random y velocity each time the program runs. Using the patterns from the last level, write the code that makes the elephant push the hippo off the screen. So this is where it'll be even more important to use what we did last time. But for now, let's run the code, see how this is working before we do anything else. Oh, my computer is really struggling. Oh my goodness, there's some text on the screen, isn't there? I didn't even notice that. Yep. Let's get rid of that. Actually, let's move that up here. so that people know where to contact me. Cool. All right. So that's my email if you want to email me. All right, write your own sprite interaction. Sorry, I read all this already. So take a second, try to write this one on your own. Notice that we're using random y velocity for the elephant. So keep that in mind. Try to create your answer. I'm going to give you a hint for how to start this. All right, we're going to use an if block. So think about if what, then what's going to happen. And I'll give you about 30 seconds or so to try to write this one on your own before I go over the answer. All right. Cool. So let's go see if you got the right answer. So you can compare your answer to mine. Push the hippo off the screen. So if is touching, right? So we want to check if the elephant is touching the hippo. We want to move the hippo. So we're going to do sprite velocity y, take the hippo, that velocity y. And this is really important. The elephant's sprite is a random number. Sorry, the elephant's velocity is a random number between -3 and -1, meaning every time we run the code, right, this code happens every time we hit run. Every time we run the code, the elephant's velocity is going to change. It's going to be different. So I can't put a number in here. I can't say make the hippo velocity 1 or -1 or 3 or whatever, because the elephant's is changing. And I can't make it a random number either, because there's no guarantee that if I said hippo velocity gets random number, there's no guarantee that it's going to be the same random number as the elephant's velocity. So we have to just tell it to literally make the hippo's velocity equal to the elephant's velocity. And that should make it work. So if the elephant touches the hippo, give the hippo an equal velocity to the elephant. Great. So now this is kind of a complicated thing going on here, right? So what we're going to do in the next activity, I believe it's in level 5, is we're going to use some abstraction to turn this whole idea into a single line of code, or at least a more condensed version of the code, so we don't have to keep writing all these lines every time we want this to happen. Okay. In the interaction-driven programming is so common that there's a block designed to do the interaction for you, sprite.displace. So sprite.displace is actually going to handle a lot of this stuff for us, rather than making us write it out line by line of the code. So someone tried to use the sprite.displace block to make the elephant push the hippo, but there is a bug. Can you change the code so the elephant pushes the hippo off the screen? So you see here, instead of having that if hippo is touching elephant, then we having multiple lines of code, we instead have this one line of code here. What we want to happen is we want the elephant to push the hippo. Here, right, we could see it saying hippo displaced elephant. Let's see how this runs in the code. Let's see what the bug looks like. We want the elephant to push the hippo. The elephant is here. The hippo is here, and what happens? Oh no, the hippo is pushing the elephant. That's not what we want. How do you think we're going to fix this? You see, right now it's saying hippo displaced elephant. So this is what I was saying a little earlier. The order for is touching, the order doesn't matter, but for displace, the order definitely matters. We're telling it, okay, we want the hippo to push the elephant, but that's not what we want. We want the elephant to push the hippo. So we need to change these and put elephant first and put the hippo second. And now, when we run the code, the elephant will push the hippo. And there we go. So we have this one line of code that takes care of that entire interaction, which is pretty cool. Moving on to the next level. Oh, we're back up to 4 viewers right now. Very good. Very good. Make sure you text your classmates to let them know that I'm doing this. It's been hard to get the word out because not everybody's checking their email or checking Google Classroom. So if you could, and if you have any of your classmates' phone numbers, or I'm sure you have contact with a lot of them via social media, make sure to share this. And you don't have to like the video. You could subscribe to my channel, so that way you know when I go live. That might be helpful. I'm doing this every day at 10 o'clock for consistency. I might go over the same lessons. I don't know. We'll kind of see how this builds as we move along. But my plan is to try to get us through Unit 3 while we're all kind of at home. All right. Let's talk about Level 6. More collision blocks. 3 new types of sprite interactions have been added to the toolbox. Collide, bounce, and bounce off. How do you think they'll affect the sprites? Switch out the displace block for collide, bounce, and bounce off. Hint, if you're having trouble doing this with blocks, switch over to text mode. Discuss with a neighbor what is the difference between the 4 sprite interactions. What is the purpose of each block? So this is a really important level. We're going to explore the differences between these different blocks of code. Hey Maria, I don't know when we go back to school. There is a lot of talk about a lot of different days going on. I don't want to say anything specifically because no plan has been set in motion. So I'm not really sure. I know this week we're closed, and next week was supposed to be spring break, I believe. So it'll be the middle of April is the earliest possible. Personally, I imagine, based on how everything progresses, that we will at least be out of school through the rest of April, but that is not a guarantee. I do not know what PG County is planning to do. So again, I don't want to give you a specific day because I don't know. Which is why I'm doing this live stream as a way to help us still be learning and interacting together. Okay, so let's switch out this displace block. Parrot displace penguin. So we want to switch out displace for collide. So right now we'll see what displace does. Parrot and penguin. So here's the parrot and the penguin. So right now the parrot pushes the penguin. But what if we use instead collide? So they did it before background. Interesting. Yes, so we could do parrot collide penguin. And I haven't done this yet, so I'm really curious to see what happens. I'm not actually sure what collide does. Interesting. It makes the penguin push the parrot. Let's see if that happens every time. Interesting. Very interesting. All right, let's see what bounce does. So, parrot, bounce, Ah, so they hit each other and then float away from each other. That's pretty cool. Wonder how that's going to be different from bounce off, if it's different at all. Parrot, bounce off, penguin. Interesting. So the penguin keeps moving, the parrot is the one that changes direction. The parrot is bouncing off the penguin. Interesting. Okay. So I think what we're going to be doing the rest of this lesson is exploring how each of those really works. So that's it for lesson 6. Let's move on to lesson 7. Or level 7, rather. There are 4 types of collisions that we use in Game Lab: displace, collide, bounce, and bounce off. These blocks will cause a certain type of interaction between the sprite and its target. So remember, when we use those, this is the sprite, and the second one is the target. So choose the best block to model the basketball bouncing off the floor. So let's run here. Read more about them in helps and tips. So we want the basketball to bounce off the floor. This right here kind of says what the answer, I think, is going to be. Bouncing off. So bounce off. We could explore with different ones, but I think reading the sentence, bounce off, right? Let's make the floor, or would bounce off the basketball. This is going to be incorrect, by the way. I'm doing this wrong on purpose just to demonstrate a point. I'm just curious what happens. And it makes the floor go the other direction. Yeah, that's not what we want. So we want basketball to bounce off of the wood. Let's run that. And it bounces back up. Cool. So it's making it look like the basketball is actually bouncing off the ground, which is pretty cool. Let's move on to level 8 of lesson 18. Thanks for sticking with me, those of you who are still watching. Again, text your friends, let them know that we're doing this, we're in here. I want to try to live stream every day. I might do a review day later this week where I just go over anything before this and let anyone ask any question. I want to give an opportunity to my students who kind of fell behind earlier in the year to maybe go back to some earlier lessons and help them out. So we'll kind of see how this works moving forward. Debugging sprite interactions. Sprite interactions just run some code when they're called. The interactions are not remembered by the game. Remembered. Let's remember that as a keyword. If you want one sprite to bounce or collide with another, then it needs to be part of the draw loop. If you forget, then this can lead to unexpected behavior. Do this. The turtle can be moved with the arrow keys. It's not supposed to be able to walk through the tree, but something is wrong in the code. Can you find and correct the bug in the code? Run the code and try to make the turtle collide with the tree. Look through the code and discuss with your partner what the problem is. Correct the code and then run it again to make sure it works. So let's run the code, and I'll be your partner, so the turtle should not be able to collide. Or sorry, what are they saying? It's not supposed to be able to walk through the tree. Okay. So the turtle goes, and it's walking through the tree. I'm going to keep holding the down arrow. So I'm pressing the down arrow right now on my keyboard. I don't know if you can hear me pressing the down arrow. So we don't want that to happen. So let's take a look here. Ooh, there's a lot of stuff going on. Key down, up, key down, key down, key down. So it looks like in the code here, we have turtle collide tree, but it's not in the draw loop, right? So if you remember, the code outside the draw loop only affects the very beginning of our code. If we want something to behave a certain way or change, or if we want something to happen after the code starts running, it has to be inside the draw loop. So this just needs to go in here. And let's run the code again. So now, no matter where we go, so it looks like the collide code is specifically, so the turtle still moves, right? But I'm going to try to move him to the right. And he just won't go into the trees. It's just stopping his velocity. So it looks like what's literally happening here is turtle collide tree. What that does is it stops the turtle's velocity. It brings his velocity to 0 as soon as it's touching the screen. Or, sorry, as soon as it's touching the tree. Ooh, my video got a like. Wow, I got a like. Thank you so much. I appreciate it. If you also like this video, you can hit like on the video if you want. Cool. So that was all there was to fix this. We needed to move turtle collide inside of the draw loop. Very cool. All right. Level 9. I need a brain break. 5-minute brain break. Maybe we should get some water. Drink some coffee. Oh no, I'm almost out of coffee. Saved 2 minutes ago. Okay. Sometimes sprites will behave in ways that are unexpected. There is a special sprite.debug property that you can use to better understand why the sprites interact the way they do. So we use this in lesson 16, I believe. These 2 coins are round, so you would expect them to bounce in a certain way. Something weird is happening though. Run the code and watch the way the coins interact. Use the sprite.debug block to make debug true for both sprites and run the code again. Alright, so we'll stop there. Let's run the code. The sprites collide. Interesting. So we'd expect them to kind of bounce and move away from each other like this, or is it like this? I don't know if I'm... I see. Okay, so I need to do this backwards. So we're expecting them to move like this, right? And bounce off each other in that direction. But what they're doing is bouncing that way, which is weird. So let's add the debug. And so debug here, set it to true. And the debug here, set it to true. And that might give us some insight into what's happening here. So we can see the way they're touching, it's not hitting corner to corner. They're kind of, there's an overlap with how they're touching each other. You can see it right watching the corner here. Watch the corner, watch the corner, watch the corner. It doesn't quite hit corner to corner. Change the gold coin starting X position to 51 and run the code again. So gold coin X position, we're changing to 51. Let's run the code again. And now each of them is still flying off in the different direction. But now it's a different direction, right? This gold coin's going the other way. So I'm going to do 50-50. So I'm changing it to 50 to see if we can get those corners to hit precisely. Weird. It's still making them bounce in different directions. So this has something to do with how bounce works. The way that the coins, they're bouncing strangely because the corners aren't touching each other, and so it's not causing them to bounce in opposite directions. It's making them kind of bounce and shift to a different direction. That's very strange. So sprites interact based on the size and shape of their collider, not the images that are assigned to them. You can only see the collider when debug mode is turned on. You can change the shape of the collider using sprite set collider, which lets you pick between a rectangle or a circle. By default, all colliders are circles. Sorry, I read that wrong. By default, all colliders are rectangles. So when we have debug set to true, we're looking at the colliders, right? The shapes of the images are circles, but what's actually colliding are those squares, right? By default, a sprite occupies a square. So they're saying the collider by default is a rectangle. Sorry, not square, rectangle. Same difference in this case. So let's find the sprite set collider block for the gold coin and change it from rectangle to circle. And the same thing for the silver coin. Add a new sprite set collider. So down here, sprite. So in our sprite toolbox, sprite.set collider. So we're going to do silver coin dot set collider and set it to circle. And now when we run the code, now those green squares have turned into circles. And now they bounce the way we expect them to. Very cool. So we should be mindful of that as we're setting our code and building our code, as we are building projects. If things are bouncing strangely, we can turn on the debug to see what's actually happening and use set collider to fix it. Very cool. Alrighty, level 11. So far, bounce off has made sprites bounce away from other objects as fast as they bounced into them. In the real world, almost everything slows down just a little bit when it bounces off something else. You can use the bounciness block to tell your sprite how much to slow down or speed up when it bounces off something else. So read the code below and press run to see the behavior of the basketball and pool ball. Use a bounciness block to set the bounciness of your soccer ball. Run the code again and see how the sprites bounce off the floor. Interesting. Yeah, the soccer ball is definitely not doing something right. It's just still going all the way up there. So the basketball and the pool ball eventually settle, right? When you drop something on the ground, when you drop something, it'll bounce, and every time it bounces, it kind of goes a little less and a little less until it settles and stops. So we need to make that happen with the soccer ball. So let's reset that. Use a bounciness block. So where are the bounciness blocks? So bounciness is something that we set before the code starts. It's a value we want the sprite to have before the draw loop even kicks in. So here's bounciness. Here it is, right at the bottom. So underneath the soccer ball, we will set soccer ball dot bounciness gets the value. Let's set it to, so basketball has 0.8, pool ball has 0.4. I would expect a basketball to be bouncier than a soccer ball. I could be wrong, but I'm going to set this somewhere in the middle to 0.6. So I'm going to run. I'm expecting the basketball to bounce the most and the pool ball to bounce the least. There we go. That seems a little more normal. Awesome. Time check. All right, so we got about 10 minutes left. We may not get through all of lesson 18. If we don't, I will continue it tomorrow. But we'll see. Okay. Finish. Okay. Flyer game. Adding an obstacle. This is the flyer game we built in the last lesson. So we built this in lesson 17. Again, if you missed lesson 17, I covered that last week. So there are videos already in the Google Classroom that you can use to watch to work through lesson 17. Flyer game. Add obstacle. This is the flyer game you built in the last lesson. For the next several levels, you'll be adding an obstacle sprite to the game using some of the sprite interactions you just learned. At the end, you'll have a chance to keep adding on ideas of your own. Do this. Add an obstacle sprite to the game. You can use whatever image you like from the animation tab, but the example shown here uses a sun. Right now, you just need to add the sprite to your game and give it an animation. Add a new sprite to your game called obstacle. So my game, this is carrying from what I built in lesson 17 in my second video. I'm going to get rid of these scale blocks just so that. There we go. So I got that scoreboard, right? So this is the way my game works. Your code may not look exactly like this unless you built my game, but that's okay. It doesn't have to look exactly the same as mine, but we're going to do some of this stuff together. So we're going to add a new sprite called obstacle. So underneath all this here, so at the bottom of all that, var sprite, var obstacle, create sprite. In the animation tab, create a new animation for your obstacle. In the example, a sun was chosen. So you can make the example, excuse me, the obstacle whatever you want. So I'm going to click new animation. Sorry, I might have gone through that a little fast. This is telling us to go to the animation tab, right? So animation up here, upper left corner of our screen, we click on animation. We want to add a new animation. So we're going down here to add new animation. And we want something to be an obstacle that would stop. So they chose the sun. I'm going to choose something different. Let's go with a vehicle. And let's make it an enemy. Enemy black. All right, back to our code. So I'm going to set the animation of obstacle to enemy black, which is the animation from here, right? You can add your own animation, whatever one that you want to use. Doesn't really matter. If you want to use the same one I used, that's fine too. But that will create our obstacle here in the middle. Cool. Use the sprite's animation. Right, we did that. Run the code. Make sure the sprite appears where you want it to on the screen. You may need to set its X, Y, and scale properties to get the way you want it to look. All right, so I don't want my my sprite to be in the same place as my character. The word I'm looking for is character. I don't want him to be in the same place here, so I'm going to move it so that it starts maybe at 100. Maybe I want him down here, right? So 100 comma 300. Cool. And let's make it a little bigger to make this a little more challenging. Sprite.scale, we'll do obstacle.scale, make him a little bigger, 1.5, see how that looks. Cool, I like that. That's a good start. All right, so we're finished on level 12. Cool. You don't want your player to be able to move through the obstacle, so you'll need to use one of the sprite's interactions. Do this. Add code to your game that prevents your player from moving through the obstacle. So if you use one of the bounce interactions, decide whether you want to reset the bounciness of your character, discuss with a neighbor which sprite interaction that you decide to use. So this is your choice. You have a choice of which one you can use. I am going to use Collide because that seemed to make the velocity stop. So we're going to do just right here. Character, Collide, obstacle. And that makes it so that the character, what happens when he hits the obstacle? He stops. Maybe I don't like that, you know? I want him to bounce off so the game still seems like it's playable. So rather than that, I'm going to use bounce off, character, bounce off, obstacle. There we go. Seems to do a little more. Boing. All right. Cool. Finish that part. So we have the interaction down. 14. Right now, your coin is moving to random locations. That means it even will appear behind your obstacle so your character can't get to it. Using sprite interactions, you can fix this problem. Add code to your game that prevents the coin from moving behind the obstacle. Don't be afraid to try out ideas just to see how they work. Discuss with a neighbor which sprite interaction that you decide to use. Is there more than one sprite interaction that works the way you'd expect? I actually don't know what's going to work here. But we want coin, right? We want to make sure our coin and our bad coin, but you may not have a bad coin, so I'll just do coin. We want to make sure that coin doesn't appear in the same place as, yeah, so we have bad coin back here behind the obstacle. We don't want that. Maybe displace? Let's try displace and see if that one works. Let's see if the obstacle displace coin. And I'm going to copy, paste, and do the same thing with bad coin. Run the code and see how that works. Oh, that was interesting. So we saw, you could kind of see it there. Let's see if we can make it happen again. So the coin, you saw it kind of move a little bit, right? The coin's moving out of the space here. So displace is making the obstacle, it's pushing the coin out of its space, which is an effective way to handle this. Let's try, instead of displace, let's try collide. Let's see how that works. Let's try obstacle, collide, coin. And then duplicate this, bad coin, reset and run. Oh, uh-oh. That made the obstacle move. Right, just see that? Oh, yeah, we don't want that to happen. So we want to try coin, collide, obstacle, bad coin, collide, obstacle. So the interesting thing here is that this looks like it's going to work the same way as displace. See, it moved the coin out. Interesting. Cool. So both of those seem to be pretty effective. All right. We could try bounce and bounce off too, but for the sake of time, we're almost at 11 o'clock here. I guess I can try to get through the rest of these levels. So this will work for now. So reset, run, finish. Looks good. Continue. So right now your colliders are all rectangular. Switch them over to circles to get more interesting and realistic bounces and collisions. So use the sprite set collider block to change the colliders of your sprites to circles. Set your sprite's debug properties to true to make sure your game is working the way you want. So which ones become circles kind of depend on what you want to see from the code, right? From each so this is going to make it, even if it's doing this, it's going to kind of bounce like that, right? So let's make the coins and the obstacle into circles. Let's make their colliders circles. So sprite set collider, bad coin, set collider to circle. Copy and paste that. Let's get that guy up here on coin as well. Coin, set collider to circle. And copy and paste. Obstacle, set collider circle, and I could even do the same thing for character. Set all their colliders to circles and see if I like how that makes them interact. Oh, I lost my character off the screen. Oh well. That's good. I'm going to set the debug on. I'm curious where the collision is located with, yeah, I'm not sure I like that with the obstacle. So I'm going to keep the obstacle as a rectangle and hit finish. Alrighty. Whew. Oh, 16 is an assessment. Perfect. So time to make this game your own by using what you've learned about sprite interactions. So in lesson 16, in level 16 here, you are going to make this game your own. So add at least one more aspect to your game that uses sprite interaction. There's some ideas below, or you can choose to add your features of your own. Make sure you're ready to share your ideas with your classmates. So in the next video, maybe in tomorrow's live stream, or perhaps more realistically, closer to the end of the week, we're going to set it up so that we can use the share button here when we're done and share our games with each other. So create invisible sprites. Right, so this is a really good idea here. Create invisible sprites at the edge of your game to keep your character from bouncing out. So you could make an invisible sprite on each boundary to make sure that the character never leaves the screen. Because right now, you know, if he goes down, 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 what's going to happen? Now he's off the screen. So I could set up an invisible sprite here that he would bounce off of, because bounce off, bounce, collide, whatever, to make sure that the character stays on the screen. You can add an obstacle of your own or just create any idea. This is completely up to you. It's an assessment level, it has that purple check mark, which means I will be looking at these and grading them eventually. I'm not sure what the timeline on that's going to be, but try to work on your own today, tomorrow, to build out your own game. All right, we're just about at the 1 hour mark. Are there any questions for me before I sign off? So I'm going to give a minute for questions. Type it into the live chat, which I will see if you have any questions. I will take the silence as a no. Give it another minute. All right, well, my email is at the top of the stream there, right around here. Looks like it's where it is on the screen for the live stream. Yep. So if you have any questions for me, please shoot me an email. I'm here to help. If you have any questions about the code, previous lessons, this is a great time. Please, please, please contact your classmates. This is a great time for anybody who fell behind on code.org to be able to go back, complete the previous lessons, and catch up. Because we can't really move super fast since we are doing distance learning. But if there are no questions, that'll be it for today. I'm going to sign off. I hope you are staying safe. Make sure that you are washing your hands several times a day. Wash your hands before you're eating. Wash your hands just whenever you think to wash your hands. And stay well. And I will see you guys on my live stream tomorrow. Bye-bye. Oh, not actually goodbye. I didn't turn this off. How do I stop? Oh, end stream. Okay, there we go.